Okay. So my name is Telmo Pestana. I'm from Portugal, and I have almost 20 years of experience on both backend and front-end development. I'm working right now at Fortress, which is the company here in Malaga. It's also one of the platinum sponsors of OpenSouthCode, and I've been working there since 2020. I've been living in Malaga for the last couple of years, and recently I've discovered a love for testing. Have you ever thought why we need tests? We need tests to check if the business rules that were given us are correctly implemented, right? So we know that when we are developing, we might be missing something. And if you write tests, but you don't care about what you developed and you check what were your business rules, you will probably find out that something was not correctly developed and there was a bug in there and you have to fix it. Also, testing prevents previous functionalities from malfunctioning, from introducing bugs in previous functionalities. It gives a lot of peace of mind when you are refactoring code, when you are moving code from a folder to another or to a different file. It also decreases the time spent doing manual testing. So if you want to deploy something, most of the companies, what they do is having a period where you do some kind of manual testing on the code that was developed before doing that deployment. By creating automated tests, you are reducing the time of those manual tests, which is great. Imagine that you have to test manual test for 3 days, and you can reduce to just 1 day because everything is automated by tests. And also the CI/CD processes that we have and that most of us use, they rely greatly on automated tests. So when you are integrating code, you want to check that the code that you are integrating makes sense and is not breaking the code that was already there. And if you are continuously deploying, you also want to know that the application that you are deploying is free of bugs. So at Fortress, in the beginning, we have this knowledge that almost everyone does, which is there is a testing pyramid. And the testing pyramid, what does it say? It says that we write a lot of unit tests, and we start by writing unit tests on our code. It doesn't matter if you are using test-driven development or you write the tests when you write after writing your code. But unit tests are the first tests that are written. And after that, we have integration tests. We write a little bit of integration tests, and we write a few end-to-end tests. So we had this knowledge, right? And we began with 65 to 70 code coverage using unit tests, but we didn't have any integration tests, and we didn't have any end-to-end tests. And we skipped altogether the integration tests, which was a mistake at that time. But we said, okay, let's try to do 75% coverage with unit tests, and let's also start writing one end-to-end test per feature. I don't know if you used Jira, but a feature for us was a Jira ticket, basically. And what happened? What happened after that strategy that we have of creating, of having that code coverage and creating one end-to-end test per feature? The end-to-end test job that we had was taking a lot of time. It was taking 30 minutes. 30 minutes for a pipeline is a lot. We wanted our pipelines to run in less than 20 minutes or less than 50 minutes, which is even better, because we want to have a constant feedback if something is breaking our pipeline or not. But if only one job is taking 30 minutes, it means that the whole pipeline is taking 50 minutes, which isn't bad, which isn't good for us. Also, we had a problem because the environment where the end-to-end test was running had several issues. Like almost every week, the environment was down for a couple hours. We had weeks where the environment was broken for a couple days or even more, and this was also a problem because the end-to-end tests couldn't run against that environment, and they were failing. And what we did basically was disabling that job, the end-to-end test job. Also, end-to-end tests are flaky. We have to accept that. End-to-end tests are flaky. Sometimes some calls take longer and then there's a timeout, or sometimes something appears before something else that we are checking and the test breaks. And even if we think, okay, I have a single test that has like a 5% test failure, this is still an issue, because you don't have just one end-to-end test on your test job, on your test suite. You have 20, 30, 40 end-to-end tests, and the probability of something fail is a lot, even if there's even if just one test has a low probability of failing. And instead of having that pyramid, we have this hourglass shape. So we have a lot of unit tests, a lot of end-to-end tests, but we don't have nothing in the middle. We don't have any integration tests. And it started looking odd for us, and we started looking on the internet what were the ideas that were there, and we found a blog by Google, actually, and the blog was basically saying, don't create more end-to-end tests. End-to-end tests are a mistake. And they analyzed their insight, and basically what they saw is that developers like end-to-end tests because there was another team that was creating those end-to-end tests, so they had less work. If you have less work, it's always great. The management also enjoyed the end-to-end tests a lot, because the end-to-end tests are basically, you can look at the end-to-end tests and you can see the user interface moving, and you can see exactly how your user behaves and acts towards your app. So it's very visual. It's great to understand what's happening. And testers also enjoyed writing end-to-end tests, because the end-to-end tests look very closely with the actions the users do. This is what happens when you are writing an end-to-end test. You have a line of code, which is basically write some text on a text box, then click on a button and stuff like that. But in reality, what they saw was something different. They saw that bugs were identified, okay, which is fine. But they also saw that they had slower delivery time, which is tied together with that third point there, because finding what's the root cause of a bug using just by looking at an end-to-end test takes time. Takes time because the end-to-end test is not very closely related with the actual code that it runs against. So they were seeing this slower delivery time, and they also were having the same problems that we have. Flaky tests, and the environments that they were using for testing, they were unstable. On the same article, they were looking at what is the true value of tests. So a failing test doesn't benefit your users. The users don't care if you identify identify bugs on production code. What they want is that your application doesn't have bugs. That's what they want. So if you are looking at only finding bugs on this phase, it's already too late. Why it's already too late? Because you already have code in there that is buggy. So you have probably, if you are using some kind of agile methodology or something like that, you will have to do what? So you have a failing test. Okay, I have a failing test, and then you have to know at least that something is failing, and then you have to create a bug, and then you have to develop a fix, and only after that your bug is fixed. And meanwhile, while it's here in red, that bug is there. So we're already late. So what do they said at Google? So let's build something testing with a better feedback loop. What does that mean? It means that the test should be fast. We can't wait for an end-to-end test that takes 1 minute, 2 minutes, 2 minutes, or 3 minutes. That doesn't make sense. It takes a lot of time, and most of the time what you want is you type code, you write code, and what happens is that you want to see if your code broke something, and if the code that you wrote makes sense against the business rules that you were given. Also, the test should be reliable, and end-to-end tests are not reliable, as we said before. So if the tests are not reliable, the developers stop trusting in them, because what you say, okay, this end-to-end test failed, but next time we run the tests, they won't fail, because it's because of unreliability, tests are flaky, yada yada yada. And that is bad, because you start to lose confidence on what you have on your on the tests you implemented. So you don't want that, because if you lose confidence, you stop looking at the outcome of your end-to-end tests, especially if your job doesn't fail your pipeline. Also, tests should isolate failures. What does that mean? It means that the code should have a small scope. End-to-end tests can have a very broad scope, and you can have the end-to-end test touching a lot of parts on your application. And you want to have a smaller scope, so it's easier for you to identify where the problem is. So I'm a front-end developer as well, and I remember having this conversation when I was developing an Angular application in AngularJS. And at that time, I was speaking with a friend of mine, and we were speaking about tests, and a friend of mine asked me, so you don't enjoy writing unit tests? And my answer is, no. I find them meaningless most of the time for the front end. Why is that? On most places where I've been, the unit tests that you create are unit tests only for your JavaScript and TypeScript code. But most of the times, you have a lot of business logic on your HTML, on your templates. So we are missing all that logic on your templates, which is bad, and it doesn't make sense, because you are missing out a lot from testing if you don't test against your templates, your HTML. So after 2 years, more or less, I think that was in 2016, I saw this on Twitter. And this guy, as you can see, a lot of people like this. 1,500. It's a lot of people. And this guy said, one of the things that started to change the minds of a lot of people. Write tests, not too many, and mostly integration. Do you remember we didn't create any integration tests at Fortress when we tried that idea of writing only one end-to-end test per feature? And that's great. Integration tests. So integration tests can be seen on these two schools of testing. I don't know if you know this, but there are two schools of testing. One is the London School. So the London School, what it says is that the unit is a class. So this is basically unit testing. A unit is a class or a function. And also, you use a lot of mocks to limit the test to just that one class. So you have a lot of power, and you can bend your test to test a lot of edge cases by all the mocking that you are allowed to do in this kind of school of testing. But there is a problem. The problem is that unit testing, most of the time, is tightly coupled with the implementation. You are, most of the time, testing implementation details. And what does that mean? It means that when you are refactoring your code, your tests will probably fail. And you have to either rewrite your tests, move your tests around, and sometimes it's quite messy to keep those tests, and you have to write the tests again from scratch. And there's another school of testing, which is the Detroit-Chicago School of Testing. So on that school of testing, the unit is the behavior. The unit is no longer the class. This is the idea of integration tests. The unit is the behavior. So you want to test when your user writes something, types in a form, fills in a form, and the user clicks a button, the user will see a model dialog saying that your form was successfully posted, successfully created. So that is a behavior, for example. It also, so the test entry is no longer the input arguments of your function, is no longer the properties of a class. The entry point is an API. In this case, can be a UI, the HTML itself. What this means? This means that we have less coupling, which is great for refactoring. We are not testing any kind of implementation details just like they do on the London testing approach, which is great. It's great for refactoring. Right now at Fortress, we have a lot of integration tests. Yesterday, the tech lead was moving around some files, and he said that it was great having those integration tests there because he could just run them, and they succeeded. And he knew that although he changed a lot the way our folder structure looked like, he knew that the code was working correctly. And there is a problem in this because sometimes the setup required for this kind of testing is harder because there is an issue there. It's because you still have to do some kind of mocking, but the mocks are not on your component. They are much under some other components, probably on your data access layer. Also, these tests are slower. But imagine on unit tests, your unit tests run in what? In 50 milliseconds. An integration test can usually take 500 milliseconds. 500 milliseconds, you won't notice that much. And even if it takes 1 or 2 seconds, it's not a big deal most of the time. So maybe that first image of the pyramid that I've shown you is not the right approach. Maybe the testing, there's another approach, and that is called the testing trophy. The testing trophy says that you have static testing. What is this static testing? Especially on the front-end side, we use a lot of JavaScript and TypeScript. And a long time ago, when we only used JavaScript, we didn't have any types, and that was a big problem. But with TypeScript, if you write types, you have it statically tested. So if you are writing TypeScript, don't write any kind of don't use the keyword any for anything. That's a code smell and should be avoided. It also says that you should create unit tests, but unit tests, unlike the testing pyramid, the unit tests are much less than they are on the pyramid. The pyramid was a very wide array of unit testing. But in here, it's just a small portion, because most of the testing will be integration tests. And, of course, you still have the end-to-end tests in there as well. So the philosophy here is that instead of writing unit tests first, you will be writing integration tests first and only writing unit tests if you really need. Most of the time, you won't need. Most of the time, you just need integration tests and good integration tests. So the advantages of integration tests, they guarantee that your components are working correctly together. So on integration tests, you do so less mocking compared to unit tests, that what that means is that you have an entry point, which is a component, and the other components are also tested in conjunction with the first component that you have. So you know that when you are writing unit tests, everything is working correctly together. Also, integration tests, much like the end-to-end tests, they resemble the way the application is used. The instructions that you have on your integration tests they resemble the end-to-end same instructions that you use for end-to-end tests, and they don't test implementation details, which is great, just like we said before. Also, integration tests have a high return of investment. What does that mean? High return of investment. It means that the time that you invest in creating tests, it's quite high, because what happens is that you have better tests. You have much confidence coming from integration tests than you have, for example, when you are creating unit tests. They are a great balance between the confidence given by the end-to-end test, because if an end-to-end test is successful, you know exactly that the end-to-end test is failing correctly. The application is correctly implemented and everything is working correctly, and it also is much faster than end-to-end tests. End-to-end tests can take. We have end-to-end tests that take 1 minute, 2 minutes, 3 minutes, and integration tests, just like I told you, integration tests take like 500 milliseconds to test 1 second or 2 in some very extreme cases. So it's like a jack of all trades. Also, integration tests, just like I said, they use fewer mocks than unit tests. It's what makes it testing your components all together. Because what's the problem with mocking? What is the problem? Mocking is a code smell. I don't know. I remember writing unit tests and thinking to myself, I'm just writing unit tests just for the sake of covering a line of code, and that's not good if you are doing that, because the mock should be only done at the boundaries of your application. It should be done on your HTTP requests, or calling a REST endpoint, a GraphQL endpoint, something like that, on your I/O operations, downloading files, uploading files to your file system, and for your database calls. Mock should only be done there. Although writing mocks can speed up your development, what you're basically doing when you create a mock, you say, I have this component, I have this other component, and I'm going to mock this component. What you're basically saying is that I don't care what happens from this component on. And if you are going to create integration tests, you want to test everything. You don't want to mock components. Next. Tests relying on a lot of mocks, they don't give you much confidence. Why? Because you are basically lying to your to you and to your test. When you create a mock, it's basically a lie that you are creating there, and it doesn't give you confidence. Which and code coverage, does it matter? I started these talks saying that we had 65% or 75% of code coverage, and then we went to 75. Right now we have, I think it's like 95% of test coverage, and even so, we have several bugs jumping out every day or every week, because code coverage, it's just a metric. Code coverage just tells you that when you run your test, the code was executed. Doesn't tell you more than that. Doesn't tell you more than that. It doesn't tell you if you have 100% coverage. It doesn't tell you that your tests are good, or you have a code base without any bugs. No, you don't. And that's why trying to achieve 100% testing coverage is, although it can be a metric that you have to achieve. Sometimes you are investing a lot of time just to test a line of code that it's too much effort sometimes to take to test some stuff. So 100% coverage isn't good and doesn't bring you anything good. It doesn't tell you if the code is working according to the business requirements. It doesn't. It doesn't. If you don't assert the right things, and if you are just writing unit tests, it doesn't tell you anything like that. But code coverage is still good to identify some edge cases. So imagine that you are looking at your code coverage report and you see a line that is not being covered. And you think to yourself, why is not that line covered? Sometimes that line is not needed at all, and you can remove code, and removing code is one of the best things you can do because it's one less instruction you have to worry about. So this is another tweet. And integration testing, we've been doing integration tests using this testing library. I don't know if you know Kenzie Dodds. Kenzie Dodds is the creator of integration tests, of testing library. And what basically Corey House is saying there is that he is no longer testing implementation details. He is now testing user experience. Before that, creating integration tests was quite complicated. We were using Angular. I think React also had something for integration tests. but everything was very complicated to me, and there are some new libraries. I think Cypress has some kind of integration testing features in there. I think it's called component testing, and I think Playwright also has something for that as well. So this is the goal. The goal is to test the user experience, and you don't want to test implementation details. Just like I said, on React, they have this library that they are no longer using, that they are deprecating, and now they say to migrate your tests to testing library React. So these are libraries that you should look at. Testing library is open source, so we are on OpenSouthCode, so everything is open source here. The library popularity, so these are the questions that are created on Stack Overflow. As you can see, we have Cypress. Cypress had a lot of traction just after 2022. I think it's going down right now because Playwright is the new kid on the block, and everyone wants to try to develop using Playwright. And as you can see, testing library, it's more or less half of the questions that we have on Cypress, and Cypress is quite popular. So I don't think it will go away this soon. We also have with these integration tests, we start thinking, can we also do this for backend? Absolutely, absolutely. And we've been doing integration testing on our backend as well at Fortress. I just can tell you for the front end. On the front end, we have a concept of backend for front end that we write in Node.js, and we use integration testing there, just like we use for our front end application that is written in Angular. But for the backend, it's not trophy. It's different. It's a little bit different. In backend, it has this different shape. Implementation details are the unit tests, integration. It's the integration tests. Integrated is not end-to-end tests, but it's integrated tests. It's testing all your microservices in conjunction. It's not called a trophy. The shape is usually referred as honeycomb because it seems like a honeycomb. But in this case, we are not testing HTML. We are testing, our entry point is not the HTML. Our entry point is the REST, GraphQL endpoints, and all that. So you are running your tests against the endpoints you create there. And again, you don't write that many unit tests. So unit tests, they are still good. I'm saying that unit tests, you shouldn't use unit tests for your testing and all that, but we still use unit tests, and unit tests have some great use cases. One of them is to test pure functions that usually require a few or no mocks at all. For example, if you have a function or a class that has a complex algorithm inside where you have a few inputs and a few outputs, you probably want to use a unit test. I remember working for a human resources company, and we had a class that calculated the salary of an employee, and that was a great use case for a unit test because it was a complex algorithm, and we were basically just providing some inputs and just checking if the outputs were correct. So when making changes to this kind of complex algorithms, you want to make sure that everything is working correctly, and sometimes integration tests don't test everything very thoroughly. So that's why you can use, and you should use, unit tests for that. They also useful to test edge cases. So if you want to reach 100% code coverage, which I already said it's not a good practice, but if you want to test that line of code that is not being covered, okay, write unit tests, write a lot of mocks just to reach that line. That's what you can do. Next, okay, yeah. So on this philosophy of honeycomb, trophy, you are writing integration tests. So you have to avoid duplicating the tests. You have to avoid covering the same code twice, one time by your integration tests and one time by your unit tests. You don't want to use that either. Otherwise, what happens is that in the future, if you have to change something, you have to change that something into places, and you are just wasting time there. You are wasting effort because the tests are already fine. You don't have to do it. You don't have to write unit tests when you already have the test covered by integration tests. And what about end-to-end tests? We didn't speak a lot about end-to-end tests, but end-to-end tests are still valid, obviously. Obviously, they are still valid. They are very useful to test, like very important flows. So they are great to test stuff that brings money to the company, let's say. And when the tests run, you know that those features are working correctly. So you want end-to-end tests for that, but only for that. Don't test stuff that is not bringing value to your application and to your company. Also, this is more generic. It's not related with the trophy or the honeycomb approach, but avoid repeating the same test over and over. So if you have an end-to-end test, and if you every time have to log into your application, don't log in every time into your application using your UI. When I say this is typing your username, typing a password, clicking a button, and waiting for login. You want to do that test only once. The other tests you can just call the endpoints that are called when you are logging in, and all the other tests should use it. Otherwise, you are basically adding, I don't know, 1 or 2 or 3 seconds per test if you are using your UI. Okay. On Fortress, we found some this kind of approach for our end-to-end tests. We divided them in two types. So we have smoke tests that have very important parts of our application, like login and some very important use cases that we want to make sure that they are not failing. And these kind of smoke tests, they run on our pipelines every time we deploy to an environment. But we also have other end-to-end tests, and we call them nightly. And those end-to-end tests contain what we have on smoke and some other tests that we have. And when you have this kind of nightly tests, don't forget to look at the outcome of the nightly test. Someone has to check them. Someone has to check the tests. Otherwise, no one will care. And 1 month in the future, someone will come up to you asking, "Why didn't you look at this end-to-end test that is failing? Why is this failing? Blah 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 blah." No. You have to look at the outcomes of all your tests, and especially on your end-to-end tests. We had this problem at Fortress. No one was looking at the nightly tests. So, conclusions for this. what we know, what we learn here and at Fortress. We learned that integration tests are great. They are closely related with how the user interacts with your application. They have a high, at least higher return of investment when compared to unit tests because you have much more confidence in them. And they are also easy to read and understand, unlike some unit tests you may write. And they are less prone for breakages when you are doing code changes. We also learned that using end-to-end tests to test everything is a bad practice. And end-to-end tests are slow and flaky and should only be created for high-value flows. And at Fortress, we basically got rid of most of our unit tests because we have integration tests and they're fine. And we only have some use cases where we have to use them. And we also know that we can use the same approach that we have for the front end on the back end as well, and we will have the same advantages. And that's it. Thank you very much. Any questions? I know everyone has an idea about testing.
Thank you so much for the presentation. I think I'm just a newbie here, but could you please explain what the difference between integration and end-to-end is? Is it integration testing? Do you actually mock the API, or what do you do there? What's the actual difference?
So the difference between the integration tests and the end-to-end tests? Okay, so the end-to-end tests, you will have the mocks on the extremes of your application. So that's what I said before. Integration tests will have the HTTP calls mocked, will have the DB calls mocked, and the I/O operations mocked. And if you want to do a true end-to-end test, you can't mock because you want to test everything in conjunction. Although I've seen people using, for example, Playwright and probably Cypress to create integration tests, but they are mocking the calls. So you can use the same library for the two things. You can use the same library for end-to-end tests and for integration tests.
Yeah.
The microphone is coming to you.
I know all these sound really good, but at the end, this is not working. But
okay.
The thing is that if, for example, after all this, do you have like specific teams of real humans?
Yes. We still have people.
With all that, when we catch most of the errors, and when we test it with different devices, different platform, different people doing dummy things. So
we still have people. We still have people creating manual. We still have people doing manual testing. Yes, but the time greatly reduced. I remember they taking, and it was two people taking like 4 or 5 days to manual test our application every time we wanted to release. And that's a lot of effort because we want to release as fast as possible. And right now, I think it's reduced to just 1 day and a half, I would say. And it's time that you are reducing, and if you want to be agile, you want to deploy like every day, right? And you can't deploy every day if you have to wait for manual testing. Yes, so you have to introduce all those automated tests to make sure that the code that you have there is working correctly. You can't be agile without that. Forget about sprints and all that. Sprints are not agile, but that's a different conversation. You want to deploy like every day or every week. We are doing deploys every 2 weeks, but we are trying greatly to reduce this to just 1 week. And by introducing more automated testing, you are reducing the time to market and the time for your deployment, right? What do you think?
But I mean, at least if you have a big feature, we always try. We have like a box with different phones, all phones, to test this big feature. If it's a minor change, we can take the risk, but then at the end, you have to value with your team.
Yes,
things.
and it's an ongoing conversation between the architect and the management at the company, because agile will make you faster deploying stuff, but sometimes you can have bugs there. But the good thing is that if you find bugs, you will be fast deploying fixes for those bugs. Whereas if you are using most of the companies are not using real agile. They basically have a waterfall process that runs every 2 weeks or every month, and waiting for that to finish is a lot of time. So if you can deploy stuff fast to your server, so your users can see the fix and they are not affected for a long time with a bug, that is what we want to achieve. Okay, I think that's all. Thank you very much.